Hey, imagine walking into a bakery and asking for a dozen donuts. You know you're getting 12, right? Now what if I told you chemistry has its own dozen, except it's called a mole? But instead of 12, a mole means a huge number 6.022 times 10 to the 23rd power. That's Avogadro's number, and trust me, it's bigger than you can imagine. Let's break it down. If I have a mole of atoms, I've got 602 sextillion 200 quintillion of them. Why do chemists use such a gigantic number? Because atoms and molecules are tiny, like really tiny. If I tried to count a mole of grains of sand, the pile would cover the whole world, miles deep. So let's get practical. How do I use the mole in real life? First, the basics. 1 mole of a substance is its molar mass in grams. For example, 1 mole of water, that's about 18 grams. Now let's say I've got 36 grams of water. How many moles is that? Simple. Number of moles equals mass divided by molar mass. So, 36 grams divided by 18 grams per mole. That's 2 moles. But what if I want to know how many water molecules that is? Multiply your moles by Avogadro's number. So 2 moles times 6.022 times 10 to the 23rd? That's over 1,200 sextillion water molecules. Mind blown, right? Here's another cool part. If I'm dealing with gases at standard temperature and pressure, STP for short, 1 mole is always 22.4 liters no matter the gas. So if I have 44.8 liters of oxygen gas at STP, how many moles is that? 44.8 divided by 22.4, that's 2 moles. Now let's connect this to real chemistry, stoichiometry. That's just a fancy way of using moles to balance chemical equations and figure out how much stuff you need or what you'll get after a reaction. For example, if I react hydrogen with oxygen to make water, the balanced equation tells me how many moles of each I need and how much water I'll get. Let's try a practice problem together. If I have 4 grams of hydrogen gas, molar mass 2 grams per mole, how many moles is that? 4 divided by 2? Yep, 2 moles. If each mole reacts with half a mole of oxygen, how many moles of oxygen will I need? 2 times 0.5 equals 1 mole of oxygen. So, to sum up, the mole is just a supersized counting unit, like a chemistry dozen. It helps me turn tiny, invisible atoms into numbers I can work with. And with a few simple conversions, mass to moles, moles to particles, or volume to moles, I can tackle any chemistry problem. Keep practicing, and the mole will become your best friend in the lab. Thanks for hanging out. See you in the next video.